So for question 5, we've actually got to form the equation ourselves from the mechanics of this. So this is our particle here, 2 kilograms, and it's moving in this direction here. So it's got some acceleration going in this direction here. But there is a force stopping it. So the force in the opposite direction here is 6x, coming back to the original point there, and it's also got a resistance force of 2v. So I've got 6x plus 2v going in the opposite direction there. So using F equals ma, the force equals the mass times acceleration. The force here going that way is minus 6x minus 2v, and the acceleration is 2, so I've got 2a here. That one there, I'm taking this way as positive, and so the acceleration is 2 times a, and the force is back the other way, a negative. Let's just put that all over on one side. So I've got 2a plus 2v plus 6x, and really that is the answer we're looking for. Actually, divide it all by 2 and rewrite this. Instead of the acceleration, I'm going to say the second derivative of the position. Instead of the velocity, I'm going to say the first derivative of the position, and then plus 3 lots of x there equals 0. That's exactly what they asked you to do. Sorry about the glare. There it is there. So solving that, so the auxiliary equation for that here, so m squared plus m plus 3 equals 0. That is going to be imaginary. Sorry, just tap that into the calculator. That is giving minus a half plus or minus root 11 over 2i. That's not pleasant. So our solution is going to be, so first of all, that part there, e to the minus a half t, and then we've got a cos root 11 over 2t plus b sine root 11 over 2t. So that's my general solution. And we're told that when t is equal to 0, x is equal to 1. So sticking that in here, we get 1 equals, that's an e to the 0 there, isn't it? So that's that. And the sine of 0, well, that's going to be 0. So we've got the cos of the cos of 0, so there's the 1. I think just we've got a is equal to 1. That's the easy one, isn't it? Yes, we've got to differentiate this. So differentiating this, so using product rule, writing the first one down and just differentiating the second one. So differentiating the second. The cos goes to the minus root 11 over 2a sine root 11 over 2t plus sine goes to the cos, so root 11 over 2b cos root 11 over 2t, and the other way around, plus differentiate this bit here, so that's minus a half e to the minus a half t, and then just write this whole thing here down. Oh, these are long. T. So putting that all in there, and we were told that when t is equal to 0, then the speed, the velocity at that point there is equal to 2, won't we? So sticking the 0 in, so we got 2 equals the 0 in, that bit's going to be 0. So here we've got root 11 over 2b from that bit there. And in the cos bit over here, so then minus a half, and that's a cos root 11 over 2, but that's 0, isn't it? So that's just 1. Take away a half there, I think. Yeah, so add that over here. I've got 5 over 2 and divide by that. I think I've got b is 5 over root 11. So I'm not finished yet, am I? So x equals e to the minus a half t. A we decided was 1. So I've got that plus b I've decided is this 5 over root 11 sine root 11 over 2t. Okay, well, it's been going on 5 minutes, so I'm going to jump to the next one here. T is equal to 2. Stick the t in all 2 equals 2 into all of that, and it gives you x equals minus 0.459 meters. And what happens as t tends to infinity for very large values of x? Well, that just really depends on this thing here, and that thing there is e to the minus a half t. Will be getting closer and closer to 0. So as t tends to infinity, and so the motion will decrease exponentially down to 0.